This is the agenda for the tutorial. We would be discussing about basic statistics, in which we'll be discussing about the various data types. What do you mean by random variable, probability distribution, so on and so forth. Post which we will get into first moment, second, third, fourth moment business decisions. We will look into graphical representations. We will build a very simple prediction model followed by some amount of hypothesis testing. I will get started right from the basics. Now let us do this. As a data scientist, the very first step is to find out what are the data types of the data which is provided to you. And the data can be broadly classified into two categories: continuous and discrete. Anything which can be represented in decimal format, which makes sense, is classified as continuous data. For example, I can say that my weight is 85 kgs. It makes sense, right? If I say I weigh 85.4 kgs, it makes sense. Despite representing in decimal format, it makes sense. If I say I weigh 85.43 kgs, it still makes sense. So the moment some data makes sense, if I represent that in decimal format, it is called as continuous data. Your price, if you go to any gas stations or petrol pumps, 1 liter fuel, 1 liter petrol would cost you what, 69 rupees? It can also cost you Indian rupees. If it says 69.6 rupees, still it makes sense for you. If it is 69.69 rupees, then still it makes sense for you, right? So if you represent something in decimal format, and if it makes sense, that is called as continuous data. Time, right? Cost, distance, all these classified to be called as continuous data. All right, then what is this discrete data? If I represent any data in decimal format, and if it does not make sense, it is called as decimal data. For example, I can say I have one laptop, or I can say I have two laptops. Can I say I have 1.5 laptops? Does it make sense? No, it doesn't make sense. If it does not make sense, it is called as discrete data. I can say I have one car, I can say I have two cars. Can I say I have 1.75 cars? Does it make sense? No. If we represent something in decimal format, and if it does not make sense, it is called as discrete data. You can probably say you have one wife or you have two wives. Can you say you have 1.5 wives? No, right? So if you represent this in decimal format, it does not make sense. Hence it's called as discrete data. This is the very first step for you. If someone gives you a data set or some kind of data, you need to first identify the data types, whether the data is continuous or discrete. Let us also discuss about this. Data types preliminaries. We have four other data type classifications. One is called as nominal. These are merely labels. For example, if I say Coke and Pepsi, if I give you the names of the products, what analysis can you perform on that? I'm just telling that Coke and Pepsi or Thumbs Up. Or if I give you names of some soft drinks, it doesn't really give you any meaningful information. However, if I move on to the ordinal data, this name ordinal is coming from order. order, ordinal. Yeah, it conveys your preference. It explains about the direction. So if you say I prefer Coke to Pepsi, I'm getting some more information as opposed to your nominal data. And that some more information is that you prefer Coke to Pepsi. So you like Coke more than Pepsi. This is the order, yeah, that you're coming to know. If I move further to interval data, it is also going to convey the magnitude of the information. So here you're saying you prefer Coke to Pepsi. But how much do you like Coke to Pepsi is not provided here, right? And here, if you say you rate Coke a 7 and Pepsi a 4 on a scale of 10. So there is a scale provided on a scale of 1 to 10, 10 being most happy or most satisfied and 1 being least satisfied. On this scale, you're saying that you rate Coke a 7 and Pepsi a 4. Now this is giving some more information. It is not just telling on what you like, but it is also telling on how much you like, right? But one thing that you need to remember in interval scale is that this is not absolute data. For example, if there are two people, person A and person B, these two people say like Coke equally well. Both of them like Coke equally. However, when you ask them to rate this product on a scale of 1 to 10, the way they're going to rate depends on each person. Both of them like Coke equally, but person A might rate this product as 9 and person B might rate it as 7. It varies. It is based on the mindset of these people, but both of them like equally this particular Coke. This problem is solved when it comes to ratio data, which has this absolute scale. For example, if there are two people, person A and person B, right? If this person pays 9 rupees or say $1 to purchase Coke, and this person B also spends $1 to purchase Coke, now I can say that both of them have spent equal amount. Anywhere on the planet, the currency will remain the same. However, when we discussed about interval scale, on a scale of 1 to 10, if these two people rated as 9, this does not mean that both of them like this product equally. You cannot say that. There is no absolute scale here. However, here, $1 each means both of them have spent same amount. Yeah. And when you do the data collection for your analysis, when you try to collect the data from your customer, you always have to look into ratio data because you can do a lot of statistical analysis on that. I'll explain each one which is given here. Not today, probably tomorrow we'll be discussing that. Right? And the richness of analysis that you can perform would increase from nominal data to ordinal data to interval to ratio. So the first preference should be given to the ratio data and the least preference should be given to nominal data, because you can perform a lot of analysis if ratio data is provided to you.